let's talk scientific revolution and kind of wrap up what's going on and really talk about the long-lasting impacts. I'm going to touch on a few people you have already learned about very briefly, and then we're going to move on. All right, so let's just kick off and talk about like what is the scientific revolution and all of that good stuff. So I want us to first remember that the Renaissance, right, during when all of this is still going on, was a time of great change in Europe. We know the Renaissance was a rebirth of learning and art. It inspired curiosity in everything. Scholars began to question ideas that have been accepted for hundreds of years from the ancient Greeks and Romans. And then you also have that religious movement known as the Reformation, which challenges the way people think about God and salvation. So those two things combined, right? We know that those are going to help spur on exploration as well, but they also help spur on the scientific revolution. And this is going to permanently change how people view the physical world around us. So before 1500, we know that people believed what ancient Greek and Roman thinkers or what the Bible had to say about the physical world. If these texts, for example, said that the earth was at the center of the universe, people believed it. It won't really, the scientific revolution it's not overnight, it's not quick. It's not what we think about a revolution in conventional terms, right? When you hear American Revolution, French Revolution, you think of something big and exploding kind of happening to make a vast direct change. Scientific revolution will take place over several hundreds of years, but its impact is what's the big revolution. So at the beginning of the scientific revolution, yes, you do have a lot of people kind of questioning old theories and you have a lot of growth going on. And exploration really does inspire people because as explorers are out there, they're encountering things they've never seen before, things that the Bible can't explain or that ancient Greek and Roman knowledge can't explain. And so when they see these ideas and they come back with these reports, scientists jump on this. And it's also important to note that scientists of this time are anti-religious. Many are devoutly religious, and they initially get into these discoveries and trying to explain and explore the world around it to support what's been said already and to support religion and to find God. And it just so happens that that's not always the case. Okay. We're going to turn to now carefully observing nature and figuring out ways to test and prove things. So we're going to get all into that. All right. So as scientists start to study the natural world around them, they realize that some of these things aren't lining up with church teachings or ancient knowledge. And so this will really lead to scientists challenging the church, even though that wasn't their initial intention, and making major advancements in science, which will continue to push forward new technologies, new explorations, and new ways of thought. So two of the guys we're going to talk about first are Francis Bacon and Rene Descartes. You guys, I believe, already touched base on them, but just as a reminder, Francis Bacon viewed experience as the most important source of knowledge. He thought that by collecting all the observable facts of nature, a person could discover the laws which govern the universe. And his understanding of the world starts with observation and experimentation. He says that scientific truth is deducted from observations and experiments. And again, he really helps get the scientific method going. Another one that we couple with the scientific method is Descartes. So Francis Bacon uses a lot of math and math in his findings, and Descartes uses a lot of observation. So together they end up making the scientific method that we know and use today. So like Bacon, Descartes believed that scientists needed to reject old assumptions and teachings. As a mathematician, he approached gaining knowledge differently than Bacon. So rather than using experimentation, he relied a lot on logic and observation and what the numbers had to say. And he believes that everything should be doubted until proved by reason, and that the only real thing that he believed could be proven was his existence. And this is where you hear that phrase, I think, therefore I am. If I'm able to make thoughts, even if it's someone controlling me or playing a prank on me, or there's some magical spirit around me that is tricking my mind, it doesn't matter because I have my own thoughts. I am clear and distinct, and I am a person. So that's where you hear that I think, therefore I am. All right, Copernicus, we've talked about Copernicus, we talked about Galileo. We're going to touch on them very briefly just to remind you. Copernicus breaks with Ptolemy's view of geocentric theory, meaning the Earth's at the center. Instead, Copernicus support the heliocentric theory, which is that the sun is at the center. So Copernicus is a little scared about publishing all of his findings with the Catholic Church, and so he does wait until his deathbed to publish his work called On the Revolutions of Heavenly Bodies. He was worried about getting excommunicated. Copernicus, while he did say that the sun was at the center, he couldn't explain the patterns of the planets moving. So he just said, they move in a circle. All right. So his assumption that the sun was at the center of the earth, or the universe, was correct. He just couldn't rectify, he didn't have the mathematical background to really figure out what was up with the planets. We're going to see that a little bit later with this guy, Johann Kepler. So most experts at the time will say Copernicus was wrong. But in the 1600s, this German astronomer, mathematician, Johann Kepler, proved Copernicus' assumptions that the Earth was at the center of the universe. And he also made discoveries that the planets move in ellipses. So like, ellipticals, like not a circle, but ellipses rather than circles, and that they move at different speeds, which is the thing that Copernicus could never figure out. Unlike Copernicus, Kepler was Protestant, and he lived in Germany, which was a Protestant accepting country. And he didn't have to fear excommunication or trial from the Catholic Church. So that's the big difference here. Protestant churches were more tolerant. So if you remember back to the video originally, there was that whole talk about how the Catholic Church at first was okay with science and then turned against it. And that's what does happen. You have a flip of the churches. Additionally, the Protestant church, remember, doesn't have damnation to hell, whereas the Catholic Church does. You remember the Catholic Church believes in excommunication, where they can say you're going to hell, you're not in the church anymore. The Protestant church doesn't have that. So in a way, they're more tolerant, but it's not they're tolerant of science. It's that they're tolerant of your sin a little differently. Just don't want it to, I hope that makes sense. Okay, so let's talk Galileo. Galileo will be tried for heresy within the Catholic Church for publishing his support of the heliocentric theory. Yeah. I can't even think right now. Sorry, guys. Okay, so Galileo in 1609 discovers moons circling other planets. And so he writes and says, because there are moons revolve around other planets like Jupiter, not all heavenly bodies, meaning moons are heavenly bodies, revolve around the Earth, and that some planets could revolve around the sun. And so he is supporting Copernicus. So he writes about all of this stuff. He publishes a book. And we know that the Pope gets mad about the book, right? Because the book goes against what the Pope says. And Galileo calls a character in his book Simplico, which means simple-minded in Italian. And the Pope's words were used for Simplico's dialogue, and blah, blah, blah. Pope gets mad. Oh, you're a heretic. Okay, we're going to try you in the church, which forces Galileo to recant all of his statements and condemns Galileo. He's put under house arrest. He's imprisoned and then moved to house arrest. His books and publications are banned, including anything he might future write. It isn't until 1992, so roughly 300 years later, that the Catholic Church formally says, we made a mistake. To each their own. Then we have Sir Isaac Newton, who we can thank for the universal law of gravitation. Remember, apple, head, all that good stuff. And at first, he thought about dropping out of school, but a teacher kind of says, no, don't do that. And he starts getting really good at math. He didn't realize how good he was at math, or this mathematical genius that he had. In 1665, an outbreak of the plague shuts his school down. Oh, man, isn't this weird? History repeating. Anyway, 1665, a plague outbreak causes his school to shut down. He goes home. That's when the whole apple falls on his head thing. And that's also where he gets this idea of gravitation and calculus. So the video you watched, it was the simplest video, but it's kind of, there's some definitely wrong characteristics in there, but you get the gist, right? And then he also uses calculus, invents calculus to kind of help with that gravitational model. So thanks, Isaac, for that calculus, which I failed. So, okay, here we go. Scientific revolution was also extremely important for art. I'm going to have some art pieces we're going to look at throughout this. But the 15 and 1600s see dramatic changes in many branches of science, especially in medicine and chemistry. And the rapid changes in science and technology that began in this period still continue today. This painting in particular is called The Anatomy Lesson of Dr. Nicholas Tulp, and it's painted by Rembrandt. And it dictates a January 31st, 1632 public dissection in Amsterdam. So public dissections were limited to one a year, and they were like the place to be. You bought tickets for it. It was in a huge auditorium. And it was like, that was the place to be seen. The men that are in this painting, these guys here with like the big white collars, they are dressed to party. All right. It was like you dressed to the nines, you were done up. This was the place to be seen and go to. And this was like the social event of the year. There's only one a year, and it had to be an executed criminal. So this guy, this corpse is Avis Kent, who was convicted of armed robbery and hung. This here is Dr. Nicholas Tulp. And then all of these men in the painting paid to be in the painting, actually. So they paid a really high price for them to be captured. Again, this was like a high profile thing. In actuality, the men would not have been close like this at all to this dissection, and Dr. Tulp would not have been the one doing the dissection. His assistant would have been, and Dr. Tulp would have been more talking about it as it was going on, but he would not have been the one actually cutting into anything. And the men, and again, it was like an auditorium, and so you looked down, like one of those medical observation auditoriums, and you looked down at what was going on. Again, a painting commission to commemorate the event and just to show that, look at me, I'm really important because I was there. All right, so let's talk about some other things that move forward. We know that astronomy, philosophy, mathematics, they all have great leaps forward, and so do anatomy and chemistry. Andreas Vesalius really takes the lead in biology and is the first one to come up with the first manual of human anatomy and founder of human anatomy as a study. So at the time prior to Andreas Vesalius, most knowledge of anatomy came from Galen, an ancient Greek, who people hadn't really tested this before. The problem with Galen is that the drawings he had, he only based them off of animals. So like it was a human body, but the insides were, like when you looked at the anatomy of the human body from Galen's perspective, it had the likeness of like an ape or a dog, for example, or a pig, because he thought that while we were different animals, all of our parts were the same. So like things were very different about the human body. Vesalius, though, took the bones and even corpses from graveyards in order to help him understand the human body. He was a grave robber, and it was very illegal. If he got caught, he would have been jailed and killed for defiling a human corpse. He would dig up graves. He would pull them if they had been hung in public. But he was able to dissect human bodies in the 1500s and makes massive discoveries within anatomy. He publishes a book on the structure of the human body, or Fabrica, in 1543, and it's the first manual of human anatomy with clear and detailed illustrations. And you can see the detail in his illustrations here. So there are several illustrations that he's done. And what he would do is he would do this in stages. So the first stage of human anatomy was he would skin the body. All right, he would take the skin off and it would just be muscle. And you can see like kind of part of that here, like this is one of muscles as well as some skeleton in there, but mostly muscles. What he would do though is instead of laying the body flat, right, because that means your muscles are at rest, he would put bodies in different positions and kind of pose them so he could learn how muscles and ligaments and joints and bones bend and which ones go together and how they are impacted. And so you can see in this painting, he's hung this person's body up by its neck. But if you look, you can also see these pieces by the hand, and those would have been leather straps that he would have pinned the body up with. And so he is documenting at each different stage how the body and muscles worked. And then to look at the bones, he would boil them. Like if you put a whole chicken in water and boil it, all the meat falls off and you left just bones and all the fat and all that. He would do that. He would boil their bones so the meat would fall off and they would just have the bones left, and then he would reconstruct their bodies to see how all the parts interact and work together. So someone's got to do it. All right, chemistry. So this is alchemist Henning Brand. And at this point in time, chemistry is known as alchemy. Now, alchemists were all about trying to turn things into something very precious that was valued. And what do you think that was? And the answer is gold. So, like other alchemists of his time, this guy, Brand, is going to search for the Philosopher's Stone, which is a substance which supposedly transforms base metals like lead into gold. So, Brand is totally invested in this. He spent his whole entire first marriage, she was very wealthy, using all of her money on his pursuit. He then marries a second wife who's extremely wealthy. She's a widow, and her funding allows him to continue his search. And the painting, this is actually her son in the background. I don't know who this guy is besides just like an assistant, but this is her son in the background, the widow's son. And this is Brand. So Brand tries to make gold from something from our bodies that humans produce that in an unhealthy way could have the same color as gold. So what do you think that is? And the answer is urine. He tries to turn human urine into gold. In one experiment, he collects over 1,500 gallons of urine from himself, his family, and his neighbors. Imagine that smell. But what he does discover, though, is phosphorus, which can be a deadly explosive, and is also used in fertilizer. So he ends up coming up with the chemical element, or discovering the chemical element phosphorus, which can now be used today to kill mass amounts of people, or to make your lawn really lush and green. So yes, urine. All right. Robert Boyle is considered the founder of modern chemistry, and you can maybe remember him because he used to have a boil, like a mole kind of cyst on his face, and his chemistry experiments actually burn off the boil on his face. So maybe a mnemonic device, I don't know. Again, at this time, chemistry is called alchemy. Alchemists thought that all matter was made up of 4 elements: earth, air, fire, and water. And it's what Aristotle taught, and it was unchallenged for over 1,000 years. Robert Boyle disproved the theory that air, earth, fire, and water were the basic elements of all matter. He argued that all basic physical properties were due to the motion of atoms. And Boyle turns chemistry into an actual science rather than alchemy. He helped establish the experimental method in chemistry and physics. Boyle's most famous contribution to chemistry is Boyle's law, and this law explains how the volume, temperature, and pressure of gas affect each other. So how does this work within like our society as a whole? You are going to really have a big questioning of the role of the Roman Catholic Church. Like, what is their role going to be? Things are changing. The church, again, is struggling with the loss of power. And as science gains more and more practicality and more following, it rolled out slowly, but as it gains more and more scientists are coming forward and really questioning ancient teachings and biblical teachings, the Catholic Church really starts to oppose those scientists, and there becomes a struggle within the Catholic Church and society. We know there's going to be a lifelong struggle. Even today, there's a struggle between the church and science and what is true and what is not true. The church will explain the world through the Bible. They'll explain it through faith. Things that you can't see to test, right? You can't physically look and test faith. And that's what the church relies on, is faith. Science, though, looks at how can we explain the world through facts and logic and reasoning and observation. And the church doesn't necessarily agree with that in this case. And so you are going to have a lot of conflict here between these two entities. And we still see conflicts today. You still have this argument of how old the earth is with some people within religion, or denying evolution. Those are things that are still argued and contentious. Like in the paintings that I showed you, and I'll show you another one shortly, artists are going to learn, again, human anatomy. So we know that this was already happening in the Renaissance. Remember, like all the massive developments in painting and how realistic things start. So these, again, things go together. History is a beautiful contribution of everything coming together. All right. And this is where you really see science and the Renaissance fueling each other. Right? We talked about this with the Renaissance. We talked about how painters started to study the human body. They started to study the way the muscles moved and how things looked underneath the skin. Those are all things that are being studied to help make art more realistic. And again, we also know that religion played a big part in these artistic achievements because religious leaders and churches would fund artists. And so again, there you have this fusion here. It all comes together. All right, let's look at this painting. So there's a lot going on here. And so I just want you to take a minute, look at it, and tell me what you see, what really stands out to you, what you're noticing. I'm going to move myself a little bit. Okay, so this painting is by Joseph Wright Derby, and this person here is a natural philosopher. That's what's going on right now. You have a gathering, and they are recreating Robert Boyle's air pump experiment. And the air pump experiment was about withdrawing air from different things and seeing how pieces responded. So in this one, it's a bird being derived of air. And you see there are a variety of reactions here, okay? You have scientific curiosity on kind of more of the left side, even the men in the middle. But at the same time, you also have sadness in like the children for this bird suffering, because that's what they're watching. They are watching this bird suffer and it's losing its life because the bird is being deprived of oxygen, of air, and they will watch it die to observe what happens in death. Okay, so scientific revolution, again, is going to firmly establish a way of thinking about the physical world. You have all of these great advancements in different areas of science as well as art. You will start really having things tracked and traced and the ability to retest and redo these experiments that are going on. And all of this will also influence architecture as you have better mathematics and, again, just like a better understanding of building materials and how that all works. Okay. Again, we are going to re-examine old ideas on government, religion, education, and economics. What are we teaching? What is the impact of this? How does this help us understand government, religion, all of these things? So like while the scientific revolution focused on science, they weren't ignoring other things in society. So then other philosophers that are involved start to ask, okay, well, if we can use reason to examine and understand our physical world, nature, the things that are going on around us, can we use this same logical reasoning and reflective and observations to solve the problems of poverty, war, ignorance, inequalities in society, all of those things? And so the scientific revolution drives us into one of our next big units, the Enlightenment, because again, it's questioning the status quo and what has been going on for so long. All right, so let's wrap it up. Causes of the scientific revolution: exploration and expansion of trade. That's a big one, okay, a big one. Continuing study of ancient authorities, because they're studying them, they're questioning them, and they're testing, and they're seeing if they're true or not. And the development of the scientific method, that push forward about like, we need to test everything. We can't just take it at face value. Let's see what the truth is. So those are some of our big causes. Renaissance and Reformation are also a big part of this. They're all going together at the same time and moving people towards new discoveries and new creations. Effects. We do have some big, long-lasting effects. So these are the beginnings of modern science. These are the basic building blocks for science going forward. There's a larger push of a belief in progress and the power of reason. So again, breaking with the church, on the church being the end-all be-all. There's that new view of the universe as a well-ordered system and that things just don't happen at chance, and that, again, we're kind of questioning that role of God here. And a bigger effect here is how this will look going forward for other areas of society. So again, like I said just previously, this is going to lead us to our next thing about the Enlightenment, as philosophers start to take on the role of scientists in the sense that they're like, well, scientists are using reason to explain things like gravity or to explain why these things react the way they do. We should be able to use those same thoughts and questioning processes to answer social aspects of our world. So you're going to see people start questioning the government at this time. We have absolute monarchs and they're in charge of everything. And so we're going to talk about that next week or next class. And then to like social systems, like inequalities, economic system, should we have capitalism, socialism, laissez-faire approach, all those things, role of women, if women are valuable or not in society. So education is going to be another one. So the scientific revolution will lead and continue this whole entire era of questioning the world around you and will lead to great progress in our society, as well as lead to, revolutions like the American Revolution and French Revolution are a direct result of the Enlightenment, and the Enlightenment is a result of the scientific revolution. So again, chain of events. Okay, guys, that's all I have for you on the scientific revolution. If you have any questions, please let me know. You have this and then step 4 that are due, and then you'll start on your absolute monarch for next class. All right, bye.